Polynomial functions, find the function. Okay, well in this video lecture, you're going to be given the specified zeros, and we're going to be asked to find a polynomial that fits that situation. Okay, so we're going to give you the zeros, find the polynomial. This video lecture requires us to remember two things that we already know. Number one, we know the factor theorem. If c is a zero, then x minus c is a factor. Okay, if c is a zero of the polynomial, if c is a root, then the factor x minus c is a factor. Number two, we just learned in a previous video lecture the conjugate pairs theorem, which tells us that if a plus bi, the complex number a plus bi, is a zero, then its conjugate, a minus bi, is also a zero. Okay, so let's find ourselves a polynomial. Okay, example one, and we're only going to do one example here. I think this will make sense from one example. Find a polynomial function f of x of degree 4 that has the zeros 1, 1, and negative 4 plus I. Okay, notice the 0, 1 is obviously a multiplicity 2. Okay, but we're going to recognize that because it's multiplicity 2, each of these factors counts as an individual factors toward our total of 4. Okay, well, first things first. Okay, so note, if negative 4 plus I is a factor, then by the conjugate pairs theorem just above, right here, negative 4 minus I is a factor. So now we have all 4 of our factors. We're only going to find this polynomial if we have all 4 of the factors. Okay, so our function, so f of x is going to equal to, well, some constant. Okay, I'll use the letter a, times x minus 1. If 1's a factor, x minus 1, if 1 is a root, x minus 1 is a factor, times x minus 1. You can notice the multiplicity of 2 here, times x minus negative 4 plus I. Again, if this is a root, x minus this is a factor, times x minus negative 4 minus I. Lots of negatives. Hopefully you're noticing how careful I'm being when I write this out. Okay, so any function of this form is going to satisfy what we're looking for here. Now we remember that the multiplier in front either stretches the graph, compresses the graph, stretches or compresses in the in the y direction, or it reflects the graph about the x-axis. In all 3 of those cases, the x-intercepts don't change. Okay? So, we just need to find a function. We'll let a equal 1. Okay, so our function, I need a bit more paper here, a bit more space, I think. Yep, I'm good there. So our function is f of x. Again, we just need to find a polynomial. So we'll just let our a equal 1 here. And we're just going to work to do the multiplication, multiplying all 4 of these linear terms together. Okay, I'm going to go ahead, while I'm rewriting this, I'm going to go ahead and distribute this negative. So this is x plus 4 minus I. I'm going to go ahead and distribute that negative, times x plus 4 plus I. Okay, again, I went ahead, as I rewrote this with a being 1, I went ahead and distributed this negative across these parentheses. Okay, let's get to multiplying. right, let's see here. This might take a bit. Let's see, I can do these first two pretty quickly. This is going to be x squared minus x is minus 2x and plus 1. Not bad. Now let's look at this here. This is going to be x squared, okay, plus 4x plus xi. Okay, now let's multiply the 4 across, plus 4x. 4 times 4 is plus 16. 4 times I is plus 4i. Minus xi minus 4i minus I squared. Okay, well let's clean up this right problem. Hopefully I did it correctly. That's a lot of math going on there. So this is, okay, let's just leave this. X squared minus 2x plus 1. Okay, what's going on here? Well, let's see. I've got a plus 4i and a minus 4i. That can go away. I've got a plus xi and a minus xi. That can also zero out. And now I have, let's see here, x squared plus 4x and 4x is 8x. Okay, plus 16, and I squared is negative 1, so this is minus a negative 1. Okay, well we can clean that up. The first factor is just fine, x squared minus 2x plus 1. This one is x squared plus 8x plus 15. Whew! Okay, wait a second. Nope. You probably caught that, didn't you? 16 minus a negative 1 is 16 plus 1. That is 17. Okay, now let's multiply some more. X squared times x squared is x to the 4th. Look at that. We've just found a 4th degree polynomial. X squared times 8x is 8x cubed. X squared times 17 is 17x squared. Okay, I've exhausted the x squared. Let's go to negative 2x. Negative 2x times x squared is negative 2x cubed. Negative 2x times positive 8x is negative 16x squared. Negative 2x times 17 is negative 34x. And I've just exhausted the negative 2x. Let's go to the 1. Oh, that's simple. Plus x squared plus 8x plus 17. Whoops, didn't need that parenthesis there. Okay, so now let's clean it all up. I have f of x equals x to the 4th. Okay, 8x cubed minus 2x cubed is 6x cubed. 17x squared minus 16x squared is 1x squared. Plus 2x plus 1x squared is 2x squared. Okay, let's see here. X's. Negative 34x's plus 8x's is negative 26x's. And then I have the constant plus 17. And there's my function. Okay, there's my polynomial function of degree 4. All done. Okay, we found the function. Now, we should note degree 4. Okay, end behavior. It's going to be it's an even function. So it's going to increase off to the left and to the right. Crosses the y-axis at 17. We have a repeated 0. We know that. So it's going to hit 1 and bounce off of 1. Okay, let's take a look at that graph. So let me get my books out of the way here. Let's slide this up. And just out of curiosity, let's take a look at this graph. We know we have two. Whoops, I'm not a little bit too high for that. We know we have, from right here, we have two imaginary or two complex roots. So it looks like we're going to bounce off 1, and that's the only place we're going to touch the x-axis. So let's go into our y equals. Okay, let's clear out this one. X to the 4th plus 6x cubed plus 2x squared minus 26x plus 17 graph. Whoops, I gotta change the window here. Okay, let's go to my window there we go, window. Let's go from -10, I gotta max out a little bit. Let's go to 50. I think that might be it. Okay, so there it is. Okay, so turns out, again, notice the end behavior mimics x to the fourth, an even function, so they both, as the ends both go to infinity, to positive infinity. It turns out we have, this is degree 4, so we should have a maximum of 3 turning points, and indeed we have 3 turning points. We only have one real number, 0, and that's 1, and its multiplicity 2. So you can see how it touches, but does not cross the x-axis at 1, or it bounces off. And then these other 2 factors here, right up here, are complex. So there's no more, the other 2 zeros are complex. So there's no more touching of the x-axis. So there you have it, how to find the function. What it essentially boils down to is a whole lot of careful algebra once you've written it out in factored form, and then you're careful to do the math.